This one you'll like too, I'm sure. I have this surface. It's a freeform surface. You can see it's actually a swept surface through 3 different profiles. And I want to put some holes down the side. Pretend this is like a fuselage, or at least a fuselage of a model airplane. And I want to put some holes down the side of this. So I can't put the holes in here. I've got to put it in a flat piece. So I have to flatten this first. So let's get it flat. So I go out here, and we have a new flattening routine. So I go flat, and I have to define a point for reference. Okay, I'm going to pick that corner right there, and we'll just go there. And so there's the flat of that. Now, before anybody gets excited, there's no physics involved in this. There's no setbacks, no K-factors, no neutral axis or anything like that. This is pure math. It uses conservation of area. What it basically does is it broke that surface into like a finite element mesh. Then it mapped those little squares down onto the flat and tried to get them in such a way that they would maintain their area and perimeter. So as to as faithful as possible represent the same area but flattened out. But it works pretty damn good. And in fact, for thin or just faces, you're just interested in the face of an object, this works pretty good. In fact, in this particular case, this is what I'm going to do. Now, I want to put an isocline down here along the edge of this. So I'm going to go back to curves, and I'm going to go up here to isocline. Now, isocline curves are currently under an old dialog called extract curve. It's one of the oldest dialogues still left in NX. We've taken it out of there and given it its own home now. It's a standalone function. We're promising you that all these curve functions, these odd, these old functions that haven't, we're eventually going to get them all into the new scheme. So isocline curve, we actually improved it a couple of releases ago, but now we've actually taken it out of its, that old environment and put it here. So I'm going to do an isocline curve. I'm going to pick this surface, 0-degree isocline, looking straight down. That would be this angle here. It was basically the silhouette curve. So there's the silhouette curve, or the 0 isocline, if you want to call it that. Shadow curve, some people call it shadow curve. Now, let's go back to here. I'm going to edit that. Whoops, I got to reorder my model first. Get that isocline ahead of the flat. Okay. Now go in here, because I have an option. I can bring along other objects in my flattening scheme. So I'm going to just take the curve with me. So now I got the curve flattened out. Now let's go in here. I'm going to use this as a sketch plane, and I'm going to draw a circle, like right there. Leave the sketch. Now come in here and use pattern geometry. Pick that along the path. There's my holes. Now I'm going to go reverse. Oh, by the way, speaking of user interface, you see down here at the bottom, I don't know if anybody's been noticing, but down here at the bottom of the screen, those are my last 10 commands. That's not part of NX11. I did that myself. But those are my last 10 commands. So now I can go down here and say I want to do the, where is it, flattening and forming. So I just go select it, see, and I'm just back to flattening and forming. Only I want to do forming, so I go to forming. And in this case, I pick my curves, my surface. Then I pick my curves. And you see, they all pop up now. They've been mapped back onto this face. So now I can go into surface, trim, grab this, grab the curves, and I got my holes. Now, if anybody would like their last 10 commands to be down here at the bottom, this only works for 9, 10, and 11 at the moment. I'll leave my business cards up here. Take a card, send me a note asking for this feature, and I will send you the files and instructions on how to set them up so that it'll work with 9, 10, and 11. You give up your bottom border bar, but I'll bet you weren't probably using your bottom border bar for anything at all, even if you knew you had a bottom border bar. So I think it's put to good use. We've actually suggested this to development, and so you may actually see this someday end up in the product as at least an option, and so on. Okay, now this will work with other things. Here's a model I actually worked on just last night. This is a transition duct, and this is flattening out that transition duct using that same technique that I just, because it'll work with multiple faces, And if you do multiple faces, it makes a single sheet body when you get done. So I mean, it handles it nicely and so on. So there's another example. And of course, it's all associative. If I go in here and pick, let's say, this sketch here and decide to change the size of it, let's say make it smaller, everything updates. So now, like I said, it's not physics-based, but for surface type stuff, or you saw me a moment ago mapping geometry from either a formed to a flattened or flattened back up to the form, it's a very good tool for that because it's dealing with the face. So like wrapping stuff around geometry, you know, geometry around geometry. It works quite nicely for that. Okay. Sam did a little sheet metal, so I won't show you sheet metal. Some drafting stuff, although before I do the drafting thing, I have to start out with this part right here. This is good enough, good as any. I'm going to put a hole in here, so I go to hole, and I'm going to put a through hole, a simple hole, and I'm going to put a hole in here. So there we go, and so there's the hole. Okay, now the way you define a hole is you define the depth of that hole. If it isn't a through hole, you define the depth of the hole as being the height of the sidewall. Now, as a designer, I might actually be more interested in where the bottom is, but manufacturing only knows about the height of the sidewall. The reason the manufacturing only knows about the height of the sidewall is because that's the only thing he can measure. If I tell a manufacturing engineer to drill a hole to a certain depth, he has to prove to me that he's actually drilled the hole to that depth within the tolerance that I gave him. How does he do that? By measuring the sidewall. That is what you give him. That's what the annotation call-out gives him, and that's what he manufactures. But we all know as designers that the hole really goes a little bit further. And if we wanted it to go to the tip, we have to work out, we have to trig out, you know, the 118 degrees and how far down that goes and so on and so forth. I suppose you could use synchronous modeling to take care of that. But anyway, the truth of the matter is the holes are defined this way until now. Now I can come in here and say by cone depth, you know, cone tip. So now I can actually control the bottom of the hole based on the cone tip. It might be important if I'm doing like the manifolds or something like that and I don't want any breakouts. Now, you haven't changed what the manufacturing guy gets. He's now going to be told this value when you run your annotation. Because all we've done is just changed how you input the information. The definition of the hole hasn't changed at all. It's a screwy number now because of the trigging out of that 118 degrees, but that's the value that'll be given to the manufacturing engineer. If I do an annotation on this hole, call out, that's what he's going to get, is the height of the sidewall, even though I have defined it to the tip. This is one of those cases where the design intent doesn't match what you give manufacturing, because manufacturing has to be able to measure its results. They cannot measure, you know, accurately to the bottom of that tip. I can design to it, but they can't measure to it. But now at least I can do it without having to trig it out myself. Let the software do the trigging. It's, after all, a computer. Speaking of holes in parts and what we tell engineers, let's go look at this example. I've got a part here that has a threaded hole in it. Now, all of you, hopefully, those of you who are on 9 and 10, realize that we added the ability to create a hole call-out using the new style here, and I'm going to add the thread depth as well. So here is the full call-out: the thread size, the pitch, the thread depth, and the hole depth. So there's my call-out. Now, that's fine if I use a call-out in this fashion. But there are some people out there who prefer to dimension their holes using the side view. In other words, linearly, rather than by call-out. So some of you may not be aware, but you can have a whole call-out using a linear dimension as well. It isn't limited to just radial dimension. And this will work with a section view as well as you know, this view here. So now I go ahead and pick this. I get a linear dimension, although it's still in the form of an annotation, and I still get the opportunity to come in here and say I want to put the thread depth in here. So here's the annotation that you would get. Okay, gives me all the same information, except I'm in this linear view. Why not take advantage of the fact that I'm in this linear view? So what I'm going to do is I'm going to undo that and start over. Only this time, I'm going to add, turn this on. I'm going to add the ability to put the linear dimensions in as well. Now, when I get done, this is an annotation. These are separate dimensions. This isn't all one big symbol. These are 3 different objects were created at one time. Yeah, it's just faster. It's quicker. If this is your normal way of working, fine. You can now dimension your holes this way. Saves you a couple extra steps. And you can still use the annotation call out for the linear part, for the size part. So you don't have to do a combination of things. Here's another drafting thing that people have asked us about. I have this part with a relatively long view that I want to shorten the view or break it. So I'm going to come in here and I'm going to break the view. So add view breaks. I'm going to put one there and one there and hit OK. And notice that the center line didn't go away. So a lot of people complained about that. Now we did cover ourselves because we used to put a message up that would flash up and says some drafting annotation was removed from the view. So we covered ourselves. We didn't tell you what annotation was removed, but at least we warned you that something was gone. And it was the center line that was gone. But now the center line is there and it's maintained and it does everything you want. And we decided to go one better. Decided, while we're at it, people are making these broken views. Let's go, so I'm going to put a linear dimension here from one side to the other. Put my dimension up here. And we'll automatically add the broken dimension to the dimension. Now that's optional. We can turn it off if you don't want to use it. It doesn't work in the sense that if I started out with a dimension and then break the view, it doesn't do it. What it's looking at is that I put a dimension across a break. So the act of putting the dimension across the break says add a break to the dimension as well. Like I said, if that's not the standard you're using in your company, you can turn that option off. So that's a little drafting enhancement that we put in there. Let's see, where am I on my schedule here? I have a few minutes left. Okay. Let me see what's on my list here that I haven't done yet. Got that one. Oh. I don't have the part open. Past week. Yeah, there it is. Okay. I have this classic example. If I wanted to trim this sheet with this one, I'm in no problem. But what if I wanted to trim this sheet using, trim this sheet using this sheet? You're going to have a problem with that, right? So let's go into trim. And so I say I want to trim this sheet, and this is the surface I want to trim with. And of course we get this message saying, you can't, because it doesn't go all the way, it ends here. And it would be the same if I drew a curve and projected it, use a curve projected down on the surface for the trim. It would, as long as it didn't break through the edges, I can't use it. Well, now we have an option for just simply say extend the object in order to go to the top. Now what it's doing is doing a normal extension, so it's just extending it out there. It's really for when you get close to the edge. You're close and I just wish it would do, okay, fine, it takes care of it. Trim and extend actually does something like this. And over time, it appears that trim and extend are probably going to get merged together, and we'll just have some options. We'll turn on and off, and there'll be a single trim, and you'll just get some options. This was kind of the first characteristic of trim and extend that we moved down to general trim, but eventually the rest of them will get there too. So that's kind of it's just to help you kind of get along with what you need. Okay, let me. Oh, yeah, here's one. How many people out here are still have left edit transform on their dial, on their menu bar? Edit transform. because you wanted to scale curves. We promised you we were going to take care of that, and we're going to deliver. So let's go in here, constrain to plane. So I'm going to pick that plane. I'm just going to draw a spline. Then I'm going to come in here and do a point to here, apply another point to here. So basically I've created a 2D profile without sketching. You know, see, there's 2D profile without sketching. But I like to scale that now. And in the past you had to use edit transform because that's the only place we left scaling of curves. You could scale solids, you could do all that kind of stuff, but you couldn't do curves. So we left it behind. Well, now we've brought it into the 21st century. Now we have scale curve. We've also added scale curve, by the way, to sketching too. So you just want to scale one curve inside of sketching. There's actually a specific scale curve function in there as well. So now I can pick the curves. I define a point. Let's take the origin point here. And, oops, I don't want the point. I want to define the point. There we go. And so now I can scale it using either a slider or an expression. Let's say 75%. So there's 75%. And I have the option of either keeping or getting rid of the input curves. And it is a fully parametric object. I can now come in here and edit it and say, gee, I want that to be 85%. So now we can scale curves, and it works in 3D. It doesn't have to be limited to 2D. It just scales it relative to the origin. And if you noticed in the scale, let's go back here to scale curve. You have non-uniform as well as uniform. So you can, if it goes into non-uniform, you can apply a separate scale in each of the 3 primary directions. So you do have full control over curves that get scaled. So that should be useful to everybody. So there's non-uniform and there's uniform. Again, putting all the little pictures up there as we can. So that's, again, we promised you eventually we were going to cover, you know, all of this stuff. So I think we're almost to the point where you shouldn't really need edit transform anymore. I think we pretty well covered everything now. If not, it's on the list. Okay, here.